This video is going to cover section 2.4, parent functions. I'm only going to cover the new functions, well, the one new function. All of the review parent functions are on page 85. X cubed, x squared, the reciprocal function, cube roots, etc. What I'm going to draw for you right now is the greatest integer function. INTX. So, excuse me, it is called the greatest integer function. Greatest integer function. It's called the greatest integer function. That doesn't really, when you see the graph, it doesn't really, that's not a fitting name. We also call it a step function. And really the name that best suits this is the floor function. The technical name is the greatest integer function, but really the floor function is best. Okay, so essentially what it means is, what is the closest integer less than the value given? What's the closest integer less than the value given? So for example, let's just make an XY table. Okay, and that's just a squiggle there. If X is 1, well, the integer that is closest to 1, less than 1 is 1. I know that sounds kind of funky. Let's say X is 1/2. 1/2 is not an integer. Integers, right? Positive, negative, whole numbers, including 0. 1/2, the closest integer less than 1/2 is 0. How about -3/4? The closest integer less than -3/4 is -1. So you kind of look at it as, that's why we call it a floor function. You take the value you're given and you push it down to the next closest integer. So for example, 0.9, the closest integer less than 0.9 is 0. How about 0.99? The closest integer less than 0.99 is 0. How about if X is 0? Well, if X is 0, you actually get 0. So if we look at this graph, and I'm actually going to put, I normally don't do this, but I'm going to put the little tick marks. If X is 0, you get 0. If X is 1, you get 1. If X is 2, you get 2. If X is 3, you get 3, and so on and so forth. If X is actually -1, you get -1. But it's what happens in between 0 and 1 that matters. So if X is, let's just look at the points that I gave you here. If X is 1/2, we get 0. Okay. If X is -3/4, we get -1. Ish. This looks really messed up. If X is 0.9, I still get 0. And if X is 0.99, I still get 0. So every value, as I'm going from X is 0 to X is 0.9, 0.99, 0.9999999, I'm getting really close, but once I hit 1, X is 1. So from 0 all the way, I'm going to try and just draw this a little bit darker here. Once I hit 1, I'm getting super close, but it's an open circle and it jumps up to 1. So if X is 1.3, the f of X is 1. If X is 1.4, the f of X is 1. The closest integer less than the given value. So we say we're pushing it to the floor. Normally we would say, oh, if X is 1.5, Y would be 1.5. No, not with the greatest integer function. So I'm going to, between values of x between 1 and 1.99999. So I get super, super close. But when x is 1, or sorry, 2. So when you get to 2, x is 1.9, 1.99, 1.99999. I'm getting close to 2. But when x is actually 2, y is 2. This is called the step function. It's also called a floor function. So for example, the values, how about some negative values? So the f of negative 1.6, the closest integer less than negative 1.6 is negative 2. If f is negative 4.7, the closest integer less than negative 4.7 is negative 5. How about the f of 12.1? The closest integer less than 12.1 is 12. So this is going to be open circle here. Etc. And your book does a calculator drawing. I'm not sure if they actually do a regular drawing of the integer function. Looking at my book here. No, they do what it looks like on the calculator on page 87, but this is the parent greatest integer function. Okay, so the domain is all real numbers. I can plug in anything I want for x. So the domain in interval notation is negative infinity to infinity, also known as all real numbers. Also known as all real numbers. The range are only integers. All you're getting out for no matter what you plug in, your output are only integers. So sometimes you'll see curly brackets, negative, boom, 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 negative 3, negative 2, negative 1, 0. Or the integer. So this is the greatest integer function, also known as the step function, also known as the floor function. It is the closest integer less than the given value that you're plugging in. So what we're going to look at now is some piecewise graphs. And piecewise graphs might be new to you, may not be new to you. We shall see. So a piecewise function means I'm going to give you a bunch of different functions, and you're going to graph a piece of them on each coordinate plane. Okay, here we go. So for the homework for these problems, you want to have nice big graphs. For these homework problems, you're going to want to have nice big graphs. Every problem should be drawn on a different XY plane. Okay, so let's look at something like such. The f of x is equal to, and I'm going to use different colors to make it easier for us to see. So let's say the f of x is equal to negative 3x when x is less than negative 1. Not sure you can see the colors all that well. 0 when x equals negative 1. And how about, what's the last one? 2x squared plus 1. When x is greater than negative 1. Okay. This is your domain right here. I want the values when x is less than negative 1, when x equals negative 1, and when x is greater than negative 1. you can find the domain without even having to graph the problem. Less than -1, equal to -1, greater than -1, the domain is all real numbers. I tend to just write the real number symbol. You can certainly use interval notation and write negative infinity to infinity, or you can write it out, that's fine. All right, so normally -3x is a line through the, actually negative, so it's this way. -3x is a line through the origin. All right, but I only want from negative infinity all the way up until when x is -1. And when x is -1, I want the graph of that line to stop. So I usually start with what I consider this to be the end point. Not equal to, so it's an open circle. Not equal to, open circle. So if x is -1, y is 3. X is -1, y is 3. Open, not or equal to. Okay, well, the slope is -3. So from here, I'm going to plot a line with a slope of -3. So we're here, 1, 2, 3, 1. You can plug in points if you want. I think we're past our plugging in point days. And here is the first piece of my graph. Normally this line would continue all the way down, but these x values are outside of the given domain. Now, when x is actually equal to -1, y is going to be 0. Equal, included, closed circle. So when x is -1, y is 0. All right. Now, 2x squared plus 1. So let's hope I don't mess this up. This is a parabola, opens right side up, and it is up 1, and it is compressed to the y-axis. Okay, so x is greater than -1, open circle, open circle. So when you plug in -1, you get 3, I believe. Is that right? Plug in -1, 2, 3, yeah. Oh. So when I plug in -1, I get 3. It's already there. Okay, great. It's already there. So you don't have to put it in a different color or whatever, it's fine. So I already have that point. Well, let's plug in 0 to see what happens. So if I plug in 0, I get 1. Plug in 2, 4, 8, 9. I think, yeah, 4, 9, yeah. So I think I should plug in 1 first. Let's plug in 1 first. You get 3. How many points do you need? You should plug in enough points where you can get a clear picture. I would plug in at least 2 or 3. So notice that this is a parabola, and I already said it was shifted up 1. Ish. Okay, this is a piecewise graph. I've drawn a piece of this line. I have drawn a piece of this parabola, and I have plotted that exact point. Let's find the range. The range of this function is funky. It appears that the range is y is greater than or equal to 0. It appears that the range is y is greater than or equal to 0, but it's not true because there's a gap between 0 and 1. Between 0 and 1, there are no y values. So my range is 0, bracket because it's a point, in union with 1 to infinity. That's a 0. Doesn't look like a very good 0. It is not y is greater than or equal to 0 because there are no y values between 0 and 1. I like to sometimes think of it as if I were to take this graph, I've got my graph, and I were to smash it along the y-axis, if I were to take like, you know, like a pancake or a waffle maker or whatever, and you smash it against the y-axis would be covered starting at 1, but not between 0 and 1. Okay, so the next question I'm going to ask you are to find some exact values. Let's find some exact values. So let's find the f of, how about -2? There's one answer to this question. The f of -2. When x is -2, a couple ways you can do it. You can look at your graph, or you can look at your domain. If you look at your graph, x is -2. That appears to be 1, 2, 3, 4, 5, 6. So you can just count it on the graph. Or you can look at this and you can say, okay, -2. -2 falls in the domain of this first function. -2 is less than -1. So you can just plug in to the first function and you can say, okay, that's -3 times -2, which is 6. One answer. You know how else you know there's only one answer? Look at your graph. Does your graph pass the vertical line test? Does your graph pass the vertical line test? It does. So I'm going to ask you one more exact value, and then I'm going to show you where your mistake might come in. So let's say that I ask you to find the f of, how about 5? Okay, so 5 is over here. I can't count on my graph. My graph doesn't even go up that high. So you have to know which domain does 5 fall under. 5 is greater than -1. So I'm going to plug 5 into this last function. 5 is greater than -1. So this is going to be 2 times 5 squared plus 1, 2551. Okay, so I'm going to show you sometimes what I see that's incorrect. And hopefully you can see the pencil when I draw it in. -3x. Oh yeah, you can see the pencil. Great. So this is what I see. Let me just draw it in solid. So I see students draw the whole line. And then they draw the whole parabola, which would be, I don't know, the other point would be like up here somewhere. So I'll see students draw in the whole -3x, and then they draw in the whole parabola. Well, this is wrong on so many levels. But the first thing is, it fails the vertical line test. It fails the vertical line test. So piecewise, give me a piece of each function. So I'm going to try to erase this. Passes the vertical line test. So this is a piecewise function. Okay, the homework, I have to check, is 19 to 33 odd, I think, but I'm not positive. You know what? Tune me out. I'll post the homework on Classroom because I know exactly what it is. But that's the greatest integer function and piecewise graphs.